Hi, welcome to Lesson 28, Session 1. Today we're going to be starting our very first, in this fifth grade year, lesson working with geometry. And so we're going to be looking at the categories of two-dimensional figures. So we'll be talking about many different figures that are two-dimensional and how they are all related. We're going to be working in our Ready Classroom Math Workbook on pages 575 through 578. So go ahead and open up your Ready Classroom Math Workbook and turn to page 575. All right, so on page 575, it says this. This is kind of what we're going to be thinking about as we're working today. How can two-dimensional figures be grouped to show that they are related? And to kind of start to make our brains kind of warm up and think about it, we're going to go ahead and start right away with the model it. So in the model it says this. Polygons are described by their attributes. So the word attributes, what does attributes mean? Well, the good news is they tell us what it means. Attributes are ways that we describe a polygon, such as the number of sides or angles they have. So they're kind of like their qualities, or the attributes is another word for qualities. They're things that make a polygon a polygon. Those are their attributes. So polygons are described by their attributes, such as the number of sides or angles they have. And then they're grouped into categories based on the attributes that they have in common. In the space below, draw an example of a rectangle and an example of a square. Then complete the table by writing 3 attributes shared by all rectangles and 3 attributes shared by all squares. So first of all, let's go ahead and we'll start with rectangles. So let's draw a rectangle. Well, I know that a rectangle looks like this. And so what are some attributes of the rectangle? What do you notice about this rectangle? Go ahead and just shout it out. Not that I can hear you, but I want you to practice. Okay, well, immediately when I look at it, I notice that the rectangle has 2 sets of parallel sides. 2 sets of parallel sides. What that means is this side here and this side here will continue forever and never touch because they're parallel. And this side here and this side here, those 2 sides will continue forever and they will also never touch. So there are 2 sets of parallel sides. I also recognize that each corner has a right angle. So there are 4 right angles. And then, you know what's funny is another thing about a rectangle that I never noticed is that they have the opposite sides are equal in a rectangle. Like I knew that, but I never paid attention to that. So opposite sides of equal length. Meaning this side here is equal to this side here, and this side here is equal to this side here. So those are 3 attributes of rectangles. And the category would be the category would be rectangles, and then 3 attributes of the shape of a rectangle are listed below. Now let's draw a square. So immediately I can see, I'm going to go ahead and keep it similar to how I did rectangles. So I'm going to start with 2 sets of parallel sides. I also see that there are 4 right angles. And then finally, I notice that when I look all the way around, there are 4 equal sides. So when I drew my parallel to show that these two lines were parallel and these two lines were parallel, I should show that I'm actually going to show it here because that's showing you that all four of those sides are equal. They're all of equal length. So 4 equal sides. So now when I look at these two pictures, what attributes do all squares have that not all rectangles have? So what does a square have that a rectangle does not have? That's right, 4 equal sides. So I want you to think about this next, about part B, and it says circle the true statement below. Every rectangle is a square, or every square is a rectangle. Think about it for a minute. What do you think it is? It is every square is a rectangle because all of the attributes that rectangles have, squares also have. And you might say, but Mrs. McGuire, this one here is different. It says opposite sides of equal length. And over here, we know that it has 4 equal sides. Well, having 4 equal sides means you also have opposite sides of equal length, because if you look at the opposite sides, they're still equal. And if you look at the opposite sides this direction, they're still equal. So they still have opposite sides of equal length, but they happen to all 4 be equal. So every square will be a rectangle, but not every rectangle is a square. Another vocabulary word we're going to learn today is called a subcategory. A subcategory is a category that shares all the attributes of a larger category. So that means, something that is a subcategory also has all the attributes of the larger category. So what we're wanting to find out is, are rectangles a subcategory of squares, or are squares a subcategory of rectangles? Since we know that every square is a rectangle, that means that a square is a subcategory of a rectangle because all squares are rectangles. So a square is a subcategory of a rectangle. Now I'm going to show you on the next page a picture kind of what that looks like, but I want you to understand that all squares are also rectangles, but not all rectangles are also squares. So go ahead and turn to page 576. All right, on page 576, it says this. A Venn diagram uses ovals or other shapes to represent categories to show how the categories are ordered in a hierarchy. A hierarchy is a ranking based on their attributes. So when we talk about a hierarchy, that means that the bigger the oval is, the higher it up it is in the hierarchy. So for example, in this hierarchy, the rectangles are all because I want to step back. I'm not going to go there yet. So let me just read this again. A Venn diagram uses ovals or shapes to represent categories and to show how these categories are ordered in a hierarchy or a ranking based on their attributes. So if we look at this Venn diagram here, it says this. How does the Venn diagram at the right show that squares are a subcategory of rectangles? So we see here that this square oval is completely inside of the rectangle oval. That means that all squares are also rectangles. But since rectangles are outside of squares, sometimes a rectangle can be a square, but not all the time. So that's why the square is inside of the rectangle and not the rectangle inside of the square. So the oval for the square, is completely inside the oval for the rectangles, meaning it's possible for a square. It's possible for a rectangle to be a square, but it's not going to be all rectangles. But all squares will always also be a rectangle. What is an attribute of a rectangle that is also an attribute of squares? So what do we know about rectangles and squares that make them both, and what is an attribute that they both have? Well, we did that on the last page. We know they both have 4 right angles. They also both have two sets of parallel sides. They have 4 sides. There's many attributes that both rectangles and squares have in common, but what's the main difference? That's right. Squares, all of those sides are equal, and rectangles, they do not have to be equal. So use what you know about triangles to write the labels isosceles triangles and equilateral triangles in the Venn diagram shown below. So we're going to look here at this Venn diagram. Now we need to talk about what we know about isosceles triangles and equilateral triangles. Now, if you're not sure, if you don't remember those from 4th grade, I'm going to show you a little trick. If you go to the back of our math book and you go back to page A1, you're going to find what's called a glossary. And the glossary is both in English and in Spanish, and it's going to give you the definitions of words that you might not know. So if we go to the E section, this is the A's. So if we go to the E section and we look up equilateral triangle, we're going to find out that an equilateral triangle is a triangle that has all 3 sides the same length. And then here's an example of an equilateral triangle where all 3 sides are 8 inches. Now let's look at isosceles triangle. So if I go in my glossary and I find the isosceles triangle, here it is. An isosceles triangle is a triangle that has at least 2 sides the same length. So an isosceles triangle, here's an example, has 2 sides that are the same or 2 sides that are equal, and the third side does not have to be equal. It can be equal, but it does not have to be equal. So isosceles triangles always have at least 2 sides that are the same length, and equilateral triangles always have 3 sides that are the same length. So now, using what we know, what is the type of triangle that is kind of the hardest to make? That's right, that's your equilateral triangle, because you have to have 3 equal sides. So that's actually going to go in the very smallest oval because it has an attribute that's really difficult that only very few shapes will have. So we're going to put that inside of this smaller oval. So we're going to write equilateral triangle inside of the smaller oval. And then in this larger oval, we can write isosceles triangle because we know isosceles triangles have at least 2 equal sides, but they don't have to have 3, but they can have 3. So we're going to write isosceles triangle here. So what that means is all equilateral triangles are also isosceles triangles because they're inside of this larger oval. But not all isosceles triangles are equilateral triangles. And we saw an example of that in the glossary, because the isosceles triangle we saw in the glossary had two sides with a length of 8 and one side with a length of 6. And that would not be an equilateral triangle. So if we're going to use our Venn diagram to complete the statement below. Blank triangles are a subcategory of blank triangles. So remember, the subcategory is the category that's inside of another category. So what is the subcategory? That's right, it's the equilateral triangle. Equilateral triangles are a subcategory of isosceles triangles, because the equilateral triangles are entirely inside of isosceles triangles. So now we're going to describe two ways an equilateral triangle has the same attributes as an isosceles triangle. So what are two ways that these two triangles are the same? An equilateral triangle has 3 angles. So they each have their, so if I had a isosceles triangle would look like something like that, where these two sides are equal. And an equilateral triangle would have 3 sides that are all equal. And they all have 1, 2, 3 angles. So they both have 3 angles, and they both have at least 2 sides that are equal. That's just like an isosceles triangle. So they both have 3 angles, and they both have at least 2 sides that are equal. And equilateral triangles have 3 sides that are equal. So if we're reflecting back, it says the question here is, based on your Venn diagram, is every equilateral triangle an isosceles triangle, or is every isosceles triangle an equilateral triangle? So we know now that every equilateral triangle is an isosceles triangle, because an equilateral triangle has not the same, has some of the same attributes as an isosceles triangle. You can pause your video and get that written down, and when you're ready, we'll go to the next page to fill out our graphic organizer. All right, over here, we've got some vocabulary words that we're going to learn about. So we've talked about these in this lesson, but I just want to make sure you understand what they are. So an attribute is a characteristic or feature of a shape. So some example of attributes of shapes are the number of sides they have, the length of the sides, and the number of angles. You could also look at if they have parallel sides, how many, well, that's the number of sides. If they're parallel, there's lots of different ways that you can describe, or the features or the characteristics, which are the attributes. The next vocabulary word is category. A category is a group of shapes that share attributes. So for example, all triangles are shapes with 3 sides. All quadrilaterals are shapes with 4 sides. Triangles and quadrilaterals are both examples of categories. And then more specific triangles and quadrilaterals that go underneath that category would be considered subcategories. And speaking of which, we've got subcategory. A subcategory is a category of shapes within another larger category. Squares are a subcategory of rectangles. And then our last vocabulary word for today is Venn diagram. A Venn diagram is a diagram that uses overlapping ovals to show how categories are related. So if we had the larger category of parallelogram, a parallelogram is a shape that has 4 sides and has 2 sets of parallel sides. Now, we know that rectangles also have, and the opposite sides are equal length in a parallelogram. So we know that rectangles also have 2 sets of parallel sides, and also have 4 sides, and also have opposite sides of equal length. However, rectangles also have 4 right angles, and not all parallelograms have right angles. So that's why rectangles are a subcategory of parallelograms. With that, I am going to, I want to go ahead and actually share with you this quadrilateral hierarchy, because we're going to talk about hierarchy. We talked about it a little bit today. So as you move down the hierarchy, that's when there are more shapes, there are more characteristics of the shapes as we move down to the square being at the very bottom of this hierarchy because it's the most restrictive shape, because it has lots of attributes that make it a square. A polygon is the most basic. It's a shape with 3 or more sides. Triangles, hexagons, heptagons, squares, rectangles, I mean, almost everything falls under the category of a polygon, other than a circle, because a circle doesn't have sides. But so polygons are any shape with 3 or more sides. Now, this is a really broad category. A subcategory for a polygon is a quadrilateral. Quadrilaterals have 4 sides and 4 angles. So all quadrilaterals are polygons. But because quadrilaterals have to have 4 sides, not all quadrilaterals are polygons. Then moving down from a quadrilateral, we have trapezoid. A trapezoid also has 4 sides. It also has 4 angles, but in a trapezoid, at least one set of parallel sides. So a trapezoid has at least one set of parallel sides. Then underneath a trapezoid is a parallelogram. A parallelogram shares all the attributes of a trapezoid, a quadrilateral, and a polygon, but what makes a parallelogram different is that the opposite sides are parallel, and that there are 2 sets of parallel sides. 2 sets of parallel sides, where a trapezoid only has 1 set. Then we get down to where we kind of take a little break. Now, we go from a parallelogram, we can make a rhombus. A rhombus looks exactly like a parallelogram because it has 2 sets of parallel sides, just like a parallelogram. It also has 4 sides, but with a rhombus, all 4 sides are equal. Now, with a rectangle is not a rhombus because the rectangle has 4 sides. It has opposite sides that are parallel, like the rhombus. However, a rectangle has 4 right angles, and a rhombus doesn't have any right angles. But then a rhombus and a rectangle, when you put them together, they become a square, because a square has 4 equal sides, which both rhombus and rectangle have. A square has opposite sides that are parallel, which both shapes have. A square has 4 right angles that a rectangle has, and a square has 4 equal sides that a rhombus has. So we kind of like branch off for a bit and then come back together. So all squares are rhombuses, rectangles, parallelograms, trapezoids, quadrilaterals, and polygons, because they are a subcategory of all of these other categories. A rhombus is a subcategory of parallelogram, trapezoid, quadrilateral, polygon. But is a rhombus a subcategory of rectangle? No, they aren't connected. So a rhombus is a parallelogram, but it is not a rectangle. A rectangle is also a parallelogram, but it is not a rhombus. So I know that picture there was a little like crazy, but I think that just having this hierarchy will kind of help you understand. You may want to pause the video here. Let me move this out of the way and take a screenshot, excuse me, so that you can see, so that you have this to reference back to if you ever need to. With that, that's the end of this lesson. I hope that you are as excited about shapes as I am. I don't know why, but I'm just having a ton of fun with these shapes.